Hey guys, this is Professor Janacek. I want to go over a few formulas for you. The first ones you've probably seen from physics in the study of mechanics. Let's start with position. That is a function of time, so we'll often write it as the function s of t. Velocity we'll write as v of t, and that turns out to be the derivative of the position function. Speed, by the way, is simply the absolute value of our velocity function. Now, displacement is the difference between the final position and the initial position. We can write that as s of b minus s of a, where a is our starting time and b is our ending time. However, by the fundamental theorem of calculus, we can write this as the integral from a to b of v of t dt. I do want you to notice that the connection between v and s comes from the equation above. Make sure you recognize that condition. Again, that comes directly from the fundamental theorem of calculus. Distance traveled, by the way, is when we integrate the speed. Future position can be determined. It is a position, so it's s of t. That can be determined by s of 0, so the position at time 0, plus the integral from 0 to some time t, v of x dx. All right, now you might have seen those, but I want to generalize these. If we're looking at any quantity, we can write it as a function q of t, so some quantity after a given time t. The rate of change of this quantity is q prime of t. You might notice a connection to the mechanics equations that we wrote at the top of the page. And so the net change would be q of b minus q of a, so the final quantity minus the initial quantity, and again, by the fundamental theorem of calculus, we can write this as the integral from a to b of q prime of t dt. So again, following the mechanics equation at the top of the page. Similarly, the future value of this quantity can be determined as q of t is equal to q of 0, so the initial amount, plus the integral from 0 to t q prime of x dx. So you may have seen the mechanics equations, but now we can generalize those for any quantity, not just a position. Enjoy!